1 plus y over x. Did y'all find the solution for the first one? I don't know.
It's question 5.
With the slope field.
Hold on, I have the answers somewhere because I've worked them before. All right, so negative 2x minus 1.
Yeah, I don't know.
Okay, star this one, and let's work that one together. Check this one.
Okay.
Negative 2x minus 1.
And they're adding, like, it's ln x plus ln 2. When you do the e, it's not adding to the not being multiplied.
Right.
Okay.
Right.
When have we ever learned that?
We did it yesterday. What are you talking about?
That doesn't even give you negative 2x.
We'll work it. We'll work it. Check your next one. Check your next one. The W. Got that one right?
We did one together.
We did this one together. Oh, man. Why did we do them all together? I didn't remember doing that.
We asked for your help.
Oh, okay. All right, there's the next. No, I love y'all.
Okay, I got that.
I needed help. I really help.
Oh, yeah, I started. I got the
All right, so we're working that one too. So that's 2 we need to work. This is the last one.
I got it.
Okay, it's been a long time ago since I've done these, so I don't remember. But we'll work them. All right, let's work them then. I saved this file. That was it. So you had what, 4, and I did one of them with you, so you had 3 by yourself, and we need to work those 3. It's okay. All right, let's do the first one. This is where dy dx equals 1 plus y over x, where x can't be 0, and I need to find the particular solution when f of negative 1 equals 1. So let's separate the variables. 1 plus y to the negative 1 dy, x to the negative 1 dx. Everybody agree? Integrate. Y'all are I hear these lollipops hitting y'all's teeth. All right, so we're gonna have some log situations here. 1 plus y log x. Everybody okay? That's what you got. All right, let's plug it in and find c. Log of, all right, so this is negative 1, 1. So this is going to be log of 2 equals log of, and remember this was really this, right? When we do the antiderivative. So it's just going to be the log of 1 plus c. The log of 1 is 0. So c is the log of 2. Okay. So now we got log 1 plus y equals log x plus log 2. I'm probably going to go ahead and combine these two before I raise it to e, just because it's a little easier. I'm going to condense that side to that. Just because I'm trying to get y by itself, and I know that I'm going to, I mean, you'll end up doing it anyway. So remember when we condensed and expanded logs? All right, if I'm adding the logs, I can condense them with multiplication. And if we go this way, remember we said that's condensing. If we go that way. Okay, so if you didn't do it, it's okay. You would just have with regular log. So they have to have the same base. So let's say log 2 of x plus log 2 of y would give me log 2 xy. If you subtract, let's say I have log 2x minus log 2y, then that's division. And then there's only one more. If you have an exponent, it comes around to the front and multiplies. Yeah, everybody likes that one. And you can go either way. You can go any way with it, backwards or forwards. If whatever you need to do that helps you in the situation you're in. Yes, yes. Because ln is just log base e. Yes. Like if it's like that, can't do anything with that. You just leave it. Yes. So if I come over here and I raise both sides to the e, or I do e to that power, it cancels those logs out. So I end up with 1 plus y equals 2x. Is that what you were asking? No. Sorry.
All right, but back to the original question, not using the
Is that what I had? Yeah, I get 2x minus 1. Is that what y'all got originally?
we all got.
Okay. Yes, no, maybe so. The logs, the algebra 2. Yeah, we did. We did an algebra 2 in pre-cal. Everybody hates logs for some reason. I love logs. I think they're easy, but everybody hates them. All right, y'all are okay on the W one that we did together yesterday? All right, flip it on over then. Oh, gross. E to the Y. All right, remember, if you know you got to solve, regardless or not, if you can get your variables separated, you generally get some credit for that. So, I know that E is the one I need to move, right? These all have X's. This is the only one with a Y. So I'm going to move this over there. And to do that, I'm just going to make this E to the negative Y, dy. 3x squared minus 6x. Y'all okay there? Y'all at least get them separated, right? Okay. Now, this, I remember a couple of you asking me about this yesterday. The antiderivative is not just e to the negative y, because I've got to account for the negative y, right? I've got to, because think about the way chain works. So when I did it, I said, well, what if u is negative y? Then du would be negative dy, which means I need a negative inside and counter it with a negative outside, essentially. Okay, so it's really going to be negative e to the negative y, or negative e to the u, and u is negative y. Does that make sense? Did I talk too fast through that?
I don't understand how negative y is.
Sure. Yeah.
Or
Antiderivative of 3x squared minus 6x is what? X to the third minus 3x squared plus c. Plug in what you got, 1 and 0. Negative e to the 0 equals 1 cubed minus 3 times 1 squared plus c. This is negative 1. Negative 2 plus c. So what is c? I forgot to cut it off, sorry. I will. I will. All right, let's plug it in. Negative e to the negative y equals, well, Robert was like staring me down as I went. That's strange. I got to get y by itself. I think I'll take care of the negative on the e first. Just divide everything by negative 1. So yeah, negative x cubed plus 3x squared minus 1. Now, how do I get y by itself? ln. ln and e cancel, so I end up with negative y equals the log of, and this is technically absolute value, 1, and then just put the negative in front. Oh, this is not necessarily absolute value. That's only whenever I do antiderivative. What? No, it's just, so if you have a natural log you need to get rid of, then you do a base of e. But if you just do this, it just gives you what, because really this is log base e of e. So whatever this exponent is up here, let's say it was x, this would just equal x. All this cancels and leaves you whatever that is. And since it was negative y, that's what I was left with, right? Ready for the next one? Are y'all feeling a little bit better about differential equations?
I feel good, and then I do one, and I'm like,
I see this, and I see this, I see everything. That's that's the antiderivative. Whenever I do the antiderivative and I get log, it's the absolute value. Okay, this one's nasty. You did this one? Did you get it right? 3 minus 2e to the negative sine x. You were close. Let's separate the variables. I think I'm gonna just move this whole piece and say 3 minus y to the negative 1 dy cosine x. I'm gonna guess if you messed up on this one, you probably had a sign error. No? Well, because with this one, when you do the antiderivative, it's not just the log of 3 minus y, but you have to chain it there. It's got to have that chain. So if u is 3 minus y, again, the du is negative dy. So I have to have a negative here.
I mean, I messed up on that.
Do what? Well, it's because this y inside is negative. So you got to think. Uh,
We had one before with it. Something like
yes, but it's because the exponent's -1.
oh,
That's why.
so it's not just because
Well, the negative's not coming from the exponent being -1, but because the exponent's -1, it makes it a log for the antiderivative. And because I'm doing this whole thing, I think you're getting confused whenever it's like this as opposed to with the exponent. Because this, I just say 3y minus 1/2 y squared. But here, I have to look at the whole quantity because it's in parentheses with an exponent, if that makes sense. I think about it as u substitution. That's what makes the most sense to me. That doesn't make sense to you? Yes.
so if it's a negative exponent,
No, she said if the variable inside's negative. Right. Not necessarily. Yeah, that has to do with the log, right? You're confusing yourself thinking about you're We'll do several more. All right. Antiderivative of cosine. Y'all can do that. Okay, sign X. Initial condition 0, 1. Negative log. Let's see. 3 minus 1. The sine of 0. Well, this is negative log of 2. What's the sine of 0? So there's my C. All right, so now I got negative log 3 minus y equals sine x minus log 2. I got this negative here I need to take care of, so I'm going to change everybody's sign. And I'm going to just switch this order up here a little bit. Y'all okay? Now what? Okay.
Where is, oh, yeah,
I would E it too. So I get 3 minus y equals what? What happens here?
2 minus, or would it be 2, negative 2?
Okay, if you, okay, I see, we all agree the first part's 2. Right, that cancels. Right. I've subtracted here. It's division, so it'd be over e to the sine x, which is the same thing if you wrote it this way, right? That's why that sine x was negative there. Okay, so either way you want to write it's fine. They're both the same thing. Right, so subtracting means that they were on top of each other, right? Because that's if their bases were the same. Or I could just keep it with a negative exponent and multiply them. It doesn't matter. Because I could think about it like that. Times negative plus negative sign. Either way is fine. No, so the ln is what causes x. Causes that to cancel out altogether. Since this one didn't have an ln, that's why the e stays on it. All right, I'm going to move the 3. That's 3. And then everybody's sign needs to change. Were they in the crate? Yes. They're in order of one. Yeah. What? Yeah. There's a rule. All right, let's take a break in between before we start growth and decay. Take